Good afternoon, everyone. My talk is not so technical like the two talks before, and I plan to share with you some of what I have experienced and what I have learned during the last 5 years or 6 years in the teaching field. So, the title I have given to my talk is Learning to Teach. So, all these years I was learning to teach, and then to do that you need to be constant. I mean, you need to have a certain attitude, which is you need to be keeping on learning. So I like this profession basically because every day you have to learn something or the other. So there are certain motivations behind this whatever work that I have done. The first motivation is all those tea time talks with Dr. Ramkumar sir. So he used to make this statement. This is not verbatim. Maybe he might not agree to this, but this is what I understood. So we cannot predict the nature of jobs that our students will be engaging in the future. A lot of you might have heard him say this several times. In such a situation, what is it that we should teach them now? So we might have our own views regarding what you should teach the student today, because we don't know what they are going to do tomorrow, what kind of job. And the second motivation is the really bad state of computer science education. I know a long time back, Namburi sir from mathematics department, he once asked me, is computer science and engineering really an engineering field? And I could not give him a very good reply because I myself was not very sure. So from that moment onwards, I started looking carefully at computer science, and this is what I really found out. So we have several stakeholders here. One is industry, most important guys, because our bread and butter comes from there. Everyone takes up engineering because of them, and they are only interested in business. And most of IT is entirely business. And then we have parents who is also a stakeholder, and their very practical concern is that our children should get good secure jobs. And then you have students. Students think IT gives a lot of money and it's a cool life inside air conditioned rooms, you can travel abroad a lot. So that is general uh, conception of students. And then academicians, quite surprising that computer science is a field where everybody from any other field is invited to work as a programmer. I found that quite surprising. I cannot go and work as a civil engineer, I cannot work as an electronics engineer, but the other way is okay. So I've been a bit harsh with the academicians. So whatever they can do, everyone can do. It definitely looks like that, or that is how we want it to be, because the specialized areas are never given any importance. Don't tell anyone it is not really an engineering. So the first question I ask myself is it really engineering? What is the engineering behind it? And faculty, definitely we all might, I definitely empathize with all these things. Covering syllabus, we are focused on covering syllabus, MBA files, invigilation duty, evaluation, and then dignified silence. Huh? Oh, don't tell anyone. Don't tell anyone. It is not really. No, 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 not technical. And dignified silence. I do not intend to be silent. I'm going to express and talk about these kind of things. Now, what is really computer science and engineering? It is programming, of course. That's the only aspect that the industry and academia has really looked into. But there are other areas like data structures. When to use what data structure is a big skill that a computer science engineer should know. And I'm not sure how many algorithms. Computation. If you ask any graduate, what is a model of a computation? What is computation? If you ask, I doubt how many will be able to give a good, convincing reply. So this is the blind spot in computer science and engineering, which means the subject itself. Rest of things people are very clear. So this is the second motivation. And so I thought every engineering field is some way associated with pursuit of reality. What is real? Like mechanical engineering, civil engineering, everything starts from a science where the science looks at science tries to understand what is real about this thing, and then let us use those theorems and mechanisms to build what we want. So we start with pursuit of reality. And I really like this picture. It's drawn by a famous, not this picture, but the concept of this picture is drawn by a very famous painter called Escher. He initially started to be a mathematician but was not very successful, so he ended up being a painter, and then all his paintings have such kind of very interesting meaning. So if you see here, these are stairs, so he is climbing up. Now this part is also climbing up, this part is also climbing up, from here also it is climbing up, but that is a optical illusion. So this is a nice picture which I want to showcase to show the current state of education. That is, every part is correct. This is correct. If you look at it in isolation, it is correct. This is correct in isolation. This is correct in isolation. This is also right in isolation. But you put all these things together, there is something wrong. It is not fitting. There is an illusion. Somewhere something is going wrong. So that is what I think we should be addressing as academicians or faculty, is that when all subjects are put together, are we doing justice to the program? So Bhagavad Gita says not only us engineers or scientists, because science and religion separation came at some point in history. Before that, it was all one. So Bhagavad Gita also says something about real and unreal. Of the unreal, there is no being. The real has no non-existence. So the real is something that is existing throughout. That is how the Eastern philosophy looked at what is real. But the nature of both these indeed has been realized by the seers of truth. So from an Eastern spiritual, religious or spirituality perspective, they were also inquiring into what is real, and that is what they found out. The seers of truth, or whoever is intelligent, knows what is the difference between real and unreal. So similar logic might be applicable to graduates also, where they need to understand the difference between what will stick, what kind of knowledge will stick or serve them in a very long career, and what might be changing, especially in computer science, since technology is changing every now and then. Today blockchain, AI, tomorrow we don't know what is going to come. Now, to look at reality and understand reality, what we really need is the right kind of perception, ability to perceive reality. Now, about perception also people have talked in the past, and I was surprised, 2018 book which talks about perception. So this is what Brahma Sutras, that is a very old document, and the commentary by Shankaracharya, and the English version of the book was released in 1936. So that book says, defines what is ignorance. Ignorance does not mean want of knowledge, like unlike what we think. We think they don't know something, that is ignorance. But here the definition is different. They say it is not want of knowledge, but that kind of knowledge which is stultified later on by the knowledge of the things as they are. So there is already some knowledge, but when they see a real thing, they realize, oh, what I knew till now was wrong. That is what they are claiming. I mean, in this book, Brahma Sutras claim as ignorance. Now let us come to a Western professor talking about ignorance and misperception. See, you can see how they have said the same thing in a slightly different manner. So they have said misperceptions differ from ignorance insofar as people often hold them with high degree of certainty. So ignorance, they say, is conventional ignorance as far as we are concerned, but then they add a new word called misperception. So the ignorance that Brahma Sutra or Swami talks about and misperception that this professor talks about are kind of one and the same. Now if you see, there is a book released recently in 2018 by Bobby Duffy, who is heading some organization in UK which does analysis of media and perceptions and how the world is generally going about. So this is a nice book to read if you are interested. Perils of Perception. So he said, our misperceptions can provide clues to what we are most worried about. So he says there is actually information in when people have misperceptions about certain things, because it shows inherent biases, and where we are not as worried as we should be. So we can actually, in the academia context, we can actually look at misperceptions. What is it that we should be giving more importance to, and what is it that we should be doing sidelining? So I find, I mean, I do a lot of thinking and research in this area. So I find there are a lot of things that we could fix with this, with respect to misperception. Our errors aren't about gross stupidity, just like what he says here. we are all subject to personal biases and external influences on our thinking that can distort our view of reality. So people are actually actively pursuing and trying to understand all these things. Excellent book, shows you a lot of statistics on. I have taken some examples from there, applied it to our students under a topic, knowing your class. And then the simple questions can be asked like, are you a good programmer? Then they will say yes. How many students in your class do you think are good programmers? So what is the perception that they have about their class? Then there are certain psychological facts that he has explained. So I have divided this pursuit of reality into Western and Eastern. So because we are both Western and Eastern, we are teaching and learning Western science, but then unfortunately the genes are totally Eastern. So Western pursuit of reality started with this guy Aristotle, and he said scientific method, objective. Today morning sir was also talking about these things, repeatability. These are the these are the foundations on which Western philosophy stands and science stands. And he said, Aristotle said, those who know do, those that understand teach. So basic, why I added this slide from Aristotle is that when we are talking about research in academia, unlike research in other research centers or companies, because teachers are people who understand. So my feeling is that if we do research in academia, then we should be contributing to understanding something, getting some insight out of something, not doing some job. So there is a huge amount of difference between these two kinds of research. Now, in this case, if you see any of the engineering fields like mechanical, civil, even computer science, any Western thought process or scientific process looks at invariance. Now, if you see Newton's laws, I mean, I was reading recently, I don't know much about this, but Lagrangian formulation states Newton's theory in terms of an invariant, that is, kinetic energy is balanced by potential energy. But I am not sure if it is being taught in civil engineering or mechanical engineering in this particular format. So there is a huge difference. Classical mechanics books are basically based on Lagrangian and Hamiltonian, but our mechanics, not sure if they are really based on those. Now, invariance is a word that you will find in computer science also, where sorting, for example, says that one part of the sorted, if you have an unsorted array, the part that gets sorted is invariant with respect to something. So the concept they have brought into computer science also. Physics is full of this concept called symmetry. Mathematics also, group, people working in group theory, they will know that there is a lot of concepts related to symmetry. So symmetry means something that needs to be preserved, but having preserved that, you can do some modifications on top. So this people use a lot to produce new engineering stuff. And the other interesting thing that I always contemplate is, how did Newton figure out that these two things, an apple falling on your head and a pendulum, are governed by the same principles? That is absolutely, I have no clue how he did that. So what is the process behind arriving at such kind of principles where two distinctly different phenomena have the same laws or underlying principles? So if we can understand, then that is what we should be teaching our students, not the phenomenon itself. So let us look at Eastern pursuit of reality. So I have taken Adi Shankaracharya's example because I had some of his books. So here it is not objective. In objective world, repeatability is important. If I can do it, you can do it. So morning sir was explaining the same thing. Here it is highly subjective. And here they call it some name, Brahman, they call the absolute reality is given this name, and the student is expected to have direct perception. It is not like the teacher says the student need to accept. That does not happen. Not a symbolic representation. You cannot put write a derivation on a paper and say I have understood the subject. That's not allowed here. And the real graduation does not happen unless you have a realization of the reality itself. So you can see certain statements. I'll just read out some of the statements. How critical they were about their analysis process. That's what I wanted to show. Not sure what they are saying is right or wrong, but they were also very, very critical, very, very scientific in their approach. If truth is one, then how does so many other experiences arises through the senses? That is something that they were asking. The scriptures do not deny the empirical validity of perception. they deny its absolute or transcendental validity. So what is really absolute? That is what they were their pursuit was. Then this is very interesting. Superposition, says Shankara, is the apparent presentation to the consciousness by way of remembrance of something previously observed in some other thing. So this is where experience can play a fool with us. So if you are experienced, the problem is you have remembrance of something. So as I'm aging, I can see that effect happening. That is, when you see a new phenomenon, the tendency is always to think of something which has happened before and then try to see if that solution will work here. And design thinking, a slide ahead will explain to you that is wrong, and you should never do that. So this is Eastern philosophy. Design thinking came now. So he says that superposition, we superimpose that thing on something that we see today, which might be a completely different phenomenon. This is interesting. The world phenomenon are neither real nor unreal, nor both. They are unspeakable or anirvachaniya. So there are problems which we have to face on a daily basis. So we need to ask: is this problem real? Should I invest my time into it, or is it unreal? And some of them are neither real nor unreal. Okay, so I'll just skip this. So now coming to that is sensitizing the audience on the pursuit of reality. So before we start with engineering and education, this is I feel the most important thing, that the students should understand that they need to understand reality, or they should be concerned about what is real and what is unreal. Now, before we go further, let us listen to what Galileo has said. Galileo says that philosophy is written in that great book, which is the universe. And understanding this, to understand this, you need to have a good grasp of a language which is based out of symbols. So Western philosophy starts off like that. Some symbols have to be defined, and then you need to reason based on that. And he was talking about the symbols. He was talking about are triangle circles, because initially geometry was thought to be the overall the real truth behind the universe. Then later on Descartes came and then said that all geometry can be also described in algebraic forms, and then now geometry means algebra. So first step in this pursuit of teaching students is we need to have a scientific process, and scientific process relies on two things. One is a system of logic and submission of proofs, mathematical proofs based on that system of logic. And the second thing is that formal description of ideas and projects using some language, like Galileo is saying we need to use some language. So students should be encouraged to use a particular language. So computer science, they learn this particular language called the language of set theory in their third semester, discrete mathematics. So they can use the language of set theory to describe their ideas and projects. So this is a small example that I have tried with one of my students, and he proved that a student can do this. Now I am trying to do it for the S4 batch computer science, and let's see how that goes. Now set theory is a very old language in which mathematicians tried to describe whole of mathematics. That is basically the work of Bertrand Russell and Whitehead. That is a history of computer science. But later on, towards the end, mathematics could not be described using set theory. Set theory. There are new languages also. Okay, I'll skip all these things. Now, once they have described it in the abstract mathematical language, they need to build models and simulate different kinds of models: abstract models, physical, cyber, and mental. I'll skip this. And two kinds of education basically. So Stephen Hawking says 21st century will be the century of complexity. We all agree. NBA is full of POs are full of complex problems suddenly out of nowhere, but it is not out of nowhere. People understand this. So I have divided knowledge into, or a kind of education, into two parts. One is reductive, that is the basic material that is given in the books, which you need to learn, and then you need to solve problems using these methods. And the other kind is complex, where you need to do more modeling and simulate, and what you need to come out with are inferences. So this is completely missing from our education. Even the reductive part is missing. That's another full presentation can be done on that. Now this is abstraction based, like box by box, but here it is interaction based. We have to give emphasis on interaction. and complex problems can be only solved through a design process, not through an engineering process. Now, what is design process? So, design process is centered on the quality of empathy, and empathy means the student should have the ability to enable customers. So, most of these things are enable customers, empower customers, and into describing their problem, finding out the right algorithm or the tool. So these are all part of the design thinking. They do not solve the problem, but they actually interact, make the interactions viable and possible. Now, teaching is a complex problem. Now, how did I realize this? Because in this book, Complex Problem Solving, I read something. I'll read it out for you. When dealing with complex problems, actors act by reducing their intellectual level by decreasing self-reflections. So now today's morning's talk was we need to be more self-introspective and all those things. It is not happening primarily because teaching is a complex problem. And there are other points also mentioned here. Now the question is, are we looking at teaching from a complex systems perspective? Are our methods based on design thinking? Are we doing simulation and modeling in the case of teaching itself? So that is another point that I thought will be interesting. Teaching is a meta problem. Meta problem means you have some activity happening which is engaging the student in day-to-day topics and solving problems, making him understand. COs are basically at one level. But then in that process, what are we teaching? So here I have said that the goal is to introduce a certain behavior. So for example, to give a concrete example here, you might be teaching him functions in C. But that is not a behavior. The behavior is if you can take a larger problem, divide it into, if the student has the ability to divide it into smaller parts and then implement them as functions, then that is a behavior. The learning how to code it as a function is only a byproduct of that. So you need to, so the goal is not to teach but to develop a behavior using a well-defined process. And the other thing is the student cannot be reduced to a number. But then what to do? Always I used to have this argument with Mahalingam when NBA documents come. I say attainment cannot be a number. You cannot reduce him to a number. Then he asked, then what? Give me another method to evaluate. I will readily change. And I didn't have an answer till now. But then, what you can do is you can convert a student into a set of relations. So has he done a problem that divides a larger complex problem into smaller problem? This you record. What are the experiences? So Ramkumar sir always used to say it needs to be an experience, and that we can capture, and the quality of the experience we can capture. I will skip all these things due to lack of time. Now, one small thing that I want to say is that to do all these things, there is something called a requirement of formality, which is imposed on symbolic systems, which is here we don't have a symbolic system. It is a student on whom we are trying to impose a structure or a system. So the student has to, for at least a little amount of his free will, he has to sacrifice for these methods to work. So meta layer, again in Eastern thought. Do I have more time? No? 2 minutes. Okay. So meta layer. So we said meta layer is emergent in teaching. It is a meta layer that Eastern philosophy also is based on meta layer. If you see this here, this is from Bhagavad Gita. As on account of the lack of knowledge of the distinction between the true self and the modifications of the intellect, the self, though verily immutable, it's unchanging, is imagined through ignorance to be the perceiver of objects like sound, etc. The self which in reality is immutable is said to be the knower because of its association with the knowledge of the distinction between self and non-self. Which is, so what it basically says is that anything which changes, so if your behavior is changing from today to tomorrow, your knowledge is changing from today to tomorrow, that is not actually you. But the meta layer which looks at all these changes, that is the real you. So they are also, they have also a similar method. Now what is it that, if I have claimed that behavioral computing is what teaching should be, so what is it that we should aim to achieve is computing lifelong and self-learning. So the student should be empowered with design thinking, formal thinking, reductive thinking, complex thinking, and eventually when they are able to arrive at insights and principles by observing a phenomenon in the world, then they will become thought leaders. And this is probably what everybody in the whole world is trying to do with education. And yeah, so that's it. I would like to end with a small quote from Sebastian Seong. Actually, I am a professor because I know how much I don't know. So that way, we are all we can all claim that we need not know everything.